Hi, everyone. Let's do a word problem. We're still in the 4.2 to 4.4 block. This is the last part there. Part G, a word problem. So for example, a 6-foot tall man like me, shut up, standing on a flat surface. So it's good to draw a picture. That's a key trick for these problems, drawing a picture. So a 6-foot tall man, all right, the 6 feet is here and also over here. And these are in feet, by the way. Standing on a flat surface as opposed to an incline. So word problems, sometimes it's tricky to state them precisely. So this man is standing on a flat surface, not a hill, and he's looking up at a 20-degree angle of elevation. Now, I'm kind of assuming that his eyes are on the very top of his head, so we're kind of ignoring the forehead. But he's looking up at a 20-degree angle of elevation, okay, up towards the top of a flagpole. So here's our flag being patriotic, right? Okay. Well, our flagpole is here, right? Our flagpole is over here. His feet are 70 feet away from the base of the pole. By the way, if you want to put a unit, that crit mark can stand for feet. Okay, let's see. His feet are 70 feet away from the base of the pole. And we have a right angle here because, again, it's a flat surface, not a hill. How tall is the flagpole? And we're going to denote the height of the pole by x. And that's going to be in feet. Now, sometimes the answer is not going to be x. For example, when we set up this right triangle problem, some people might want x to be the actual side of the right triangle here, and then the answer would be x plus 6 in feet. But the way I'm setting it up, x will represent the answer in feet. Okay, now the man is 6 feet tall. So we have this rectangle down here that's 70 feet by 6 feet. And on top of the rectangle, there's a triangle. Now, the overall height of the pole is x in feet. We have 6 feet corresponding to this height, this line segment. So this side of the triangle is given by x minus 6 in feet. And we're going to use that as part of SOHCAHTOA. X minus 6 is the length of this leg for the right triangle. Okay, so we ultimately want to solve for x. We have an angle. We have the adjacent side. It's 70 feet. We want to know about the opposite side. So what trig function relates an angle, the opposite side, and the adjacent side? It sounds like TOA. SOHCAHTOA. Sounds like a tangent problem. All right. Tangent of 20 degrees is opposite over adjacent. X minus 6 in feet. So x minus 6 in feet over 70 feet. Which means that the feet units will cancel out. The top is in feet. The bottom is in feet. Tangent of 20 degrees has no unit. It's a strict ratio. Tangent of 20 degrees is x minus 6 all over 70. We want to solve for x. First, let's get rid of the 70 on the right side. We're going to multiply both sides by 70. Time for some algebra. 70 times tangent of 20 degrees equals x minus 6. And then to solve for x itself, we're going to add 6 to both sides, 6 feet. So, and now I'll turn it around. X equals 6 plus 70 times tangent of 20 degrees. 6 is in feet, 70 is in feet. Tangent of 20 degrees has no unit. X will be in feet. Now be careful, don't add 6 and 70. We do not get 76 here. A scientific calculator should know that the product comes first. And make sure your calculator is in the appropriate mode, degree mode. 20 is in degrees. So make sure you're in degree mode. We get to the nearest tenth of a foot, about 31.5, and we should put a unit, feet, because these were in feet. It's a consistent unit. Nowadays, more and more, it's good to write down the final answer using proper English sentences. The flagpole is about 31.5 feet tall. Okay, that was the question. What is the height of the flagpole? It's about 31.5 feet tall. All right. Once again, if instead, I'll put this in purple. If instead the height of this triangle were x in feet, then the height of the pole would be what? X feet plus 6 feet, well, that's going to be x plus 6 in feet. Which means if you were to make the height of this triangle x, then your answer, the height of the flagpole, would require you to add 6 feet. So make sure that you get the height of the flagpole. Your final answer may not be x. If you make this x, your answer will be x plus 6 in feet. But we set it up here so that x is the height of the pole. The flagpole is about 31.5 feet tall. Again, remember the units in your final answer. And try to avoid approximating until the very end. Many people are tempted to round off things right in the middle, but then you're in danger of losing accuracy. It is good to try to keep things as exact as possible along the way, like we did for logs back in chapter 3. If you do round off, make sure you use many significant digits just to be safe. Okay, in section 4.8, I discussed some general principles for word problems, but really you have to practice them. In fact, when you actually practice these word problems, the hardest part for many students is figuring out which side is which length. So they're doing a word problem and students aren't sure, well, is this value this leg? Is it this leg? Or is it the hypotenuse? And that depends on the word problem. That's hard to teach. You get it from practice. But what are some general principles for word problems? First of all, well, read the problem carefully and highlight as appropriate, underline or highlight, in case you have to keep going back to some information. Define variables, like you might say, let x be the height of the flagpole. Draw a diagram and label them. Sometimes that's a decent substitute for this, but technically you should always define your variables, preferably in words. But diagrams help a whole lot. If anything, the diagram is more useful to a student. In calculus, by the way, you'll need to keep track of which aspects of the problem stay fixed or constant and which aspects change. For example, in ladder problems, let's say we have a ladder leaning up against a wall, and it's on the flat ground here. The length of the ladder tends to stay constant, but this leg here and this leg here can vary as the ladder slides around. So in calculus, you have to keep track of what stays constant and what changes. Y and X could be changing, but this could be a constant, like 15 feet. Make appropriate unit conversions where appropriate. So for example, if Y here is in inches and X here is in feet, then you have to convert from one to the other. They both have to be in inches or they both have to be in feet. It's one or the other. They have to be consistent. They can both be in inches or they can both be in feet, or even some other unit, as long as you're consistent. So make sure you get to 1 unit. Sometimes the problem will give you red herrings, numbers that don't really matter. For example, if I say in the year 2020, this happens, you probably won't need the 2020. So ignore red herrings. They're there to trick you. Make sure you clearly answer all the questions you are asked. Answer all the questions you are asked. Okay? And sometimes X does not represent the final answer. So for example, in our flagpole problem, if X is just the length of this leg, then X plus 6 in feet is the height of the pole. That's what you would really want. Sometimes X is not your final answer. Now in a math class, you're expected to give exact answers, but in word problems, you might be asked to round them off. So be aware of what the question is asking for. So again, in math class, we expect exact answers, but in word problems, we're often asked to approximate or round off and follow the instructions in the word problem. If you do round off, use many sig figs just to be careful. In your final answer, write units where appropriate, like feet in our example. And in fact, we tend to prefer complete sentences nowadays. See if your answer makes sense. So if I claim here that this flagpole is 1,000,000 miles high, you probably made an error. I would bet that you made a conversion error. For example, uh, uh, maybe you should have converted from inches to feet or vice versa, and you didn't do that. Again, be prepared to write your final conclusions using plain English sentences. In these days of Common Core, we tend to prefer that. Okay, so those are some principles of word problems, but the bottom line is you have to practice them. I'm going to discuss techniques that are specific to right triangles in the next video.